talk about is observability and high-performing teams. As the lovely gentleman just said, my name is Charity. You can tell I'm from ops because that's how I feel about software. The only good diff is a red diff. I've worked at a bunch of places. Recently, I work at Honeycomb.io. We just announced this week that we just raised another round. So we're going to be around for 2 more years. Yay. It's exciting to get to go back to work now. Anyway, so in this talk, I kind of want to talk about 3 central questions. What does it mean to be a high-performing team? Why should you actually care? And conversely, if you care, how you can make other people care too, because one person caring isn't enough. That's really noisy. Let's see if I can take these out. And number 3, how can any team become a high-performing team? Like, is it just something that only the ex-Googlers of the world get to inhabit, or is it something that is actually accessible to all of us? And fortunately, like, we now have some science. Have you all read Jez and Nicole and Jean's amazing book, Accelerate? I feel like we've been cargo culting a lot of best practices for as long as I've been in the industry. Like, someone has something that they saw work pretty well at a company that they used to work at, and so it becomes like, it's almost like a DNA. There are like a few different, like, oh, that's better, isn't it? Whew. Ha 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 ha. Okay. Test and prod. Anyway, so they surveyed thousands of teams, and they realized that you can actually tell how high-performing a team is by just asking for 4 metrics. How often do you deploy? How long between when you merge to master and when your code is live? How quickly can you recover from an outage? And how many of your deploys fail? Like, this makes it much more concrete and clear for us, right? It's not like, well, it feels good, and, we're spending like 30% of our time. It's really just these 4 things. And what that means is that if we put energy and pressure into these 4 things and make them better over time, the ripple effects for the rest of your engineering organization, for the rest of your company, can be huge, right? Oh, and P.S. Teams that use platforms as a service are 1.5 times more likely to be elite. The way they defined elite is, well, here, I'll show you. On-demand, multiple deploys per day, takes less than 1 hour to go live with your changes, less than 1 hour to restore service, and 0 to 15% change failure rate, which to me still sounds pretty lax. Very much achievable, right? But it really, really, really pays off, because if you look at the delta between teams that are high-performing and teams that aren't, you can see how quickly you can get outcompeted by teams that can move faster and with more confidence. So what does it mean? What do elite teams, what are they made up of? Well, obviously, they're made up of all ex-Facebook, ex-FANG employees, MIT grads. As a dropout music major, I would like to represent for the non-elites in the audience who nevertheless can build really fucking awesome teams. Elite teams, in my experience, and I've been in this industry for a long time, I've been on call since I was 17. That's over half my life. Elite teams are made up of ordinary engineers, ordinary skill level, who care about their work, who communicate with each other, who invest in the right things. I think of it as like doing tech out of anger, because working on the things that must be worked on, not because, oh, this framework looks cool, blah, 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 blah. That's not going to lead to a great team, right? But focusing on those 4 questions and making those metrics better, and being fully empowered to do the work that needs to be done, right? Like, if you break apart this chain, like if you have no ability to do what needs to be done, it doesn't matter how clearly you can see things. And it doesn't matter how much will and desire you bring to this if you can't actually see what's going on. So I think instead of elite, I really like to use the term excellent, right? What we need is production excellence. We need production excellence. My coworker Liz Fong-Jones has a great talk about this, which you should all watch. We need it because happier customers, happier teams. Every engineering team has a dual mandate, right? Make your users happy, but also make your team happy. And this work really begins with observability. Because if you can't, if you don't wipe off the dashboard of your car before you start driving down the road, it just makes everything a lot harder. Like I said, two constituencies, and a lot of times people, and they'll be very hard-nosed business folks, and they'll be like, it's all about users. We're obsessed with users, right? Amazon, their mission is like, obsessed with users. They never say anything about being obsessed with happy teams. And this is short-sighted. This is short-sighted, and in the end, it will damage you. Because engineering excellence is tightly correlated with happy, well-rested, empowered engineers. So next, let's talk about the way things are changing and why this suddenly matters. Systems are changing, problems are changing, this means that people have to change. This is always scary, right? We hate change as human beings, as animals. Like, it's scary. So let's walk through the hows and the whys. So systems, complexity is going up the roof, as everyone here knows, I'm sure. Our systems are now ephemeral, dynamic, loosely coupled, distributed. Basically, if you look at the architectural graphs, on the one side we see our humble lamp stack. In the middle is a diagram of parse, when I was working there a few years ago. And on the left is the national electrical grid. And when you're building systems these days, I would argue, what you should have fixed in your mind is that left side. You should be building systems like they're the national electrical grid, like they are far-flung, loosely coupled, distributed, like you have no ability to predict what's going to go on, like failure is a given, you have to make friends with it. Some problems are going to be only hyper-local, right? You have to zoom way in to see, like a tree fell over on Market Street in San Francisco. Could you have predicted that? No. Should you have written a monitoring check for it? Also no. Should you invest in gathering detail at the right level of abstraction so that you can ask any question of your systems to understand any state that they can get into, whether or not you could predict it? Yes, right? Some problems are hyperlocal. Some you can only see if you zoom way, way out. Like if a certain component, say every bolt that was manufactured in 2013 is rusting 10 times as fast as all of the other bolts, right? Like this happens all the time in our data centers. Last year's batch of RAM, oopsie, we have to proactively replace it a lot faster, right? This happened at the Facebook data centers. This means that our tools for understanding them have to shift away from the known unknowns where, lamp stack, I would look at it, I could eyeball it and guess 80% of the ways it would ever fail. So I'd write a bunch of monitoring checks for those things, right? I would page myself. I would write up run books, right? And then, over the next 6 months, we'd kind of bake it in. I'd learn the other 20%. And, once or twice a year, I'd be really, truly stumped. What the hell is going on in my lamp stack, right? Very, very rare. Well, it happens every goddamn day with modern systems, right? In fact, it's so much so that, this precedes a shift from monitoring to observability, obviously, right? From a world where you could predict what was going to happen, you'd write checks and you'd write run books, to a world where you've pretty much automated those things away. And every time you get paged, it should be something new that takes your creative engineering brain, like, that again. Shouldn't be that. It should be, I'm stumped every time you get paged, right? Well, this means that our tool set needs to change in other ways too, to make it more explorable, to make it more so that we can start assuming that we know nothing and quickly break it down to figure out exactly what's going on every time. Or, we're just bad at understanding our systems. We're really bad at understanding our systems. Every one of you, I assume, has had the experience of getting paged, starting to try and figure out what was wrong, getting the recovery, and everyone just kind of looks at each other like, we don't know what happened. Are we going to invest the rest of our day into trying to figure it out? Probably not. Very rarely, right? It's fine. It's probably fine. But we really don't understand what's happening most of the time. And I will illustrate this. Here is a problem. Photos are loading slowly for some people. Not everyone, just some people. And this is in the lamp stack era. And here are some of the things that we probably could have predicted and will definitely happen. Right? Cool. Monitor for these. Great. The need for monitoring doesn't go away. Now, let's look at the same question But all of these scenarios were taken from real instances that we had at Instagram and Parse. I'm not exactly sure what to monitor for, but I've got more. Latency reverts to historical mean on Tuesdays. I know what you're thinking, but it's not a cron job. I could do this all day. That one in Romania was probably one of my favorite outages ever. We start getting these reports that like, pushes are down. I'm like, pushes are not down. Like, I'm getting pushes, and they're in a queue. Ergo, pushes are not down. And like days later, they're still very upset. Pushes are down. So we go and start figuring it out. And I don't know if this is still true, but it used to be that Android devices all used to have to keep a socket open to the push notification server so they could subscribe to pushes. So we would run it in an auto-scaling group, so we'd load balance using round-robin DNS, so they'd bring up new capacity, it would smooth out over all the servers. And so we had added capacity one day, no big deal, we do this all the time. It all came up, started serving traffic like normal. Turns out the round-robin DNS record had exceeded the UDP packet size because we now had too many entries. And that's fine, usually totally fine, because it's supposed to fail over to TCP, which it did everywhere in the world, except for this one router in Romania. And again, I ask you, like, what exactly am I supposed to monitor for, right? Like, there's just, instead of having like a few things to monitor for that are relatively, that we can write runbooks for, instead it's like we have this infinitely long, thin list of things that almost never happen, except once they do. Or, it's 5 impossible things that all have to converge in order for this one bug to get triggered. P.S., this makes staging basically useless. They're all completely unknowns, may never have happened before, probably will never happen again. So the workflow that we've had, which is, for years we've been like, okay, we encounter a new error, cool, let's have a retrospective, let's post-mortem it, let's write a monitoring check for it, let's build a graph for it so we can find it immediately the next time by looking at this one dashboard, and then we'll write a monitoring check so that we get paged, we know what it is, right? Well, okay, fast forward a few years later, and we're getting page bombs of like things that are in no way related to the actual problem. And we have tens of thousands of dashboards, and you can't jump directly to the one that describes this exact problem because whatever was serving its data has probably stopped shipping it at some point. And it just doesn't work. P.S., welcome to distributed systems. We are all distributed systems engineers now. I think that means you get to ask for a raise. So let's mull over a few of these in a little bit more detail, the technical aspects and the cultural associations, because I think it's really interesting to think about the way that some of the cultural pathologies that we all love to rage about actually proceed very directly from technical choices and tooling that we have created over the years. Look at the LAMP stack. It's famous for having the database, the one, the database, the application, right? And because it has these characteristics, we grew up with monitoring and metrics which are inherently incapable of handling high cardinality data. So like, any of you ever start using Datadog or whatever, and you're like, I know it would be a nice tag to be able to group my metrics by hostname. And that worked until you had a few dozen hosts, and then suddenly you blew out the cardinality of the key space, and Datadog's like, pay us billions of dollars, and it won't work. Well, cardinality is important. Turns out now, everything's a high cardinality problem because there are many of everything. Because we felt we had the illusion of control, because we felt like we had a handle on the ways that our systems were going to break, we saw failure as a thing that should be prevented, right? We put all this energy into preventing failure, and it was terrible, the site should never go down, and this is where ops people have some shame to bear, we built these walls to keep people out. We taught people to fear production. We taught them to leave it to us, right? Which led to all of the, the self-abuse that ops people are known for, right? Masochistic on-call culture, that's what I'm looking for. And we treated deploys like they were scary, Like they were things to be feared and prepared for and gripped really tightly so that nothing bad would happen, right? I think of it as like we built this glass castle, and it was beautiful. It's fragile, forbidding edifice, and it was very hostile to exploration and experimentation. Well, the world is changing in many, many, many ways, right? So let's look at the technical aspects and cultural associations for distributed systems. We've got many storage systems. And I'm not saying that all these are good things. As someone with a database background, it makes my eyes bleed how many databases people like to use these days, but fine. I'm down. I'm hip. There's a lot of services. Every unknown, every alert should be a new thing. It's entirely an instrumentation game. In fact, this is driving DevOps. This is a big part of the reason that we have DevOps, is that the people with the original intent in their head who are writing code have to see it through. You have to see it all the way out to watch users using it in production. If you break that up, you're screwed, right? Like, nobody can if they don't have the original intent in their head, they can't understand what the hell is going on, right? And your job as a developer is not done until you see users use it, because there are too many tweaky things that will go wrong in the process. And then deployment, instead of being like these big bangs where we like grip real hard and we like heave it over the wall, it's more like baking cookies. You have to think of deployments more like you're putting them in the oven and you're beginning the process of gaining confidence in your code. It's just the start, right? It's just the start. You should never trust your code when you're putting it out in prod. This is why we write, progressive deployment stuff and automatic checks that'll roll back if errors exceed. All of these safety things that we bake in to do these things automatically are done because we know we can't trust this code, right? But it needs to be. I think of it almost like development. The development process is smearing all the way over into production, and the prod process has to be like smearing all the way back into dev, so that it's more like it's just a continuum, right? Production is where your users live. Failures have to become your friend, and this is just frankly because there's just too many of them. We have to embrace them. We have to embrace them. We have to make friends with them. We have to, become at home with the idea that. In reality, you've got so many things failing right now that you don't even know about. So sleep well. It's kind of black humor, but it's also true that your software is way more broken than it is correct at any point in time. That's fine. That makes deploys opportunities. That makes every outage an opportunity. I find this actually very cheering. I believe that this is the only way that we move forward to a more humane industry, is by just accepting the human frailty of all of our systems. Best practices, you build it, you run it. 3 years ago, when I started talking about putting software engineers on call, people got very angry. People were very upset. And now I think that debate is actually over. It's more, the only question is how, right? But the trade-off here is that in exchange for everyone agreeing to be on call to support their code, management has an equal responsibility to make sure it does not suck. It should not. Those of us who are over 30 who don't want to get woken up in the middle of the night anymore, we should be able to not plan our lives around being on call, right? It should not be life impacting. It should not be a thing that you dread or that's terrible. And if your management isn't carving out the time that you need to invest in systems so that they aren't hellish, you should quit your job. Seriously. Don't reward bad management with the gift of your labor. So here's the dirty little secret. The next generation of systems is not going to be built and run by burned out, exhausted, tired people who can't communicate with each other. And they're not going to be run by teams who are just following orders, who just check in at the beginning of the day and check out and don't really bring their full creative self. They're just too complex now. They're too hard, they're too chaotic, you can't just learn the system and then watch it. It doesn't work that way. Every day is learning. Every day is something new. And if you don't love what you're doing, that's going to be exhausting. You need to love it. It should be lovable. Two sides, right? But I like this because when I think about, our tools were designed for a much more predictable world, and you might have looked into this future and thought that this would be scary and terrible and doom, doom, doom. And it could be, but I actually think that all of the incentives are kind of lining up in the right direction to make it a better place. Anyway, philosophical blah, blah, blah. But let's talk about the tools. One of the things about tools is that, like, the last couple generations of tooling for understanding our systems, in fact, like monitoring, metrics, logging, they were really organized around the idea of answering questions quickly. If you had a question, they would answer it fast. And they do that very well. But when I think about the kinds of problems that I'm having, I'm usually dealing with a situation where I have maybe some problem reports that I may or may not trust. I have a hazy, like, idea that something over there, like, reminds me of something that I might have seen once that might be wrong. I've got some leaps of fancy. I've got some suspicions. What I don't have is a question. And in fact, by the time that I've worked my way to the point where I have a question that I can ask, I probably know the answer too, right? Because finding the answer, it turns out, is much easier than figuring out what the question is. And so we need to shift tooling to a much more exploratory, open-ended way of interacting with our systems. And we also need to pull all of the state about these systems out of our heads and put it into a tool where everyone can access it. First of all, we can't fit them in our heads anymore. Did I mention that they're ephemeral and dynamic and changing every 15 seconds? If you're trying to reason about how the request is making it through the system in your head, you've forgotten something. You've left it out, right? And more to the point, what's in your head is not available to your team. And this will hold us back, right? We need to have either you have a single source of truth or you have multiple sources of lies, and that includes what's in your head. I think that it's really important that we kind of release I love being the genius, who's like, I remember, like, I could look at a dashboard at Parse, I could just go, by the curve of that graph, I can tell you the fault is Redis. I feel like a freaking genius. I kind of miss that. I do. I'm not going to lie. But what I don't miss is the fact that when I was on my honeymoon, I got called like half a dozen times because nobody else could fix MongoDB, right? There are upsides, there are downsides. On balance, I think that it's fair. So next I want to talk about how observability directly leads to these high-performing teams, and in fact, why you can't really do it without observability. And Liz and I came up with a maturity model, and we distilled really everything that we've ever seen or experienced about high-performing teams into these 5 things. And I'll go through them really quickly. And they come with pairs of lists, right? Where one list is, if you're doing well in this area, then you should resonate with this. You should be like, yes, this describes me. In which case, cool, move to the next one, right? Because the other list is these are pathologies. These are signs that you're not doing well. So for resiliency, right? If you're like, yes, all of these describe me, cool. You don't need to invest in resiliency, right? We have a limited number of engineering cycles. And part of what the next generation of systems involves is learning to think ruthlessly about where to spend those cycles. This is why I'm always telling people to fuck staging, because it's a black hole for your engineering time. It's probably not going to get you the answers that you want. By the time you do get the answer, it's probably out of date. Spend your scarce engineering cycles on production. So for resiliency, right, ultimately, on-call is not extremely stressful. And that leads to low turnover, which is nice. On the flip side, if your outages are frequent, if you have alert fatigue, if troubleshooting is hard, then this is a place to invest in. And observability helps here because it gives you context. Because there is such a difference between being on a team that is invested in instrumentation, that has the ability to just take any problem report and just slice and dice, oh, I see, it's happening for, all the users who are using iOS, who are in this country, who are using this release, that sort of thing that is open-ended, that you don't have to have experienced before, versus teams that are just pattern matching based on shared trauma, or like the last outage, or they see one spike in a graph and they're like, I know what this means, and so they've only got like a corner of the answer. Honestly, it's really hard to describe to people what this looks and feels like, because like we've had like zero churn ever at Honeycomb. The hard part is getting people to experience it on their own systems, because everybody knows that demos can be faked. Everybody knows that fake data isn't real. But once you've experienced the ability to interact and like explore and just ask any question, understand any result, it's like night and day. It really is. It's like putting your fucking glasses on before you go drive down the road. And I'm really blind. Like, you do not want me to drive without my glasses. That's how I feel about having observable systems. High quality code is another one, right? If you're doing well, you spend your time on customer happiness, not on customer bugs, right? Subtle distinction. And cascading failures don't bite you all the time. The thing where you're like, oh, there's a bug here, and you go to fix it, and suddenly your week is shot because, nobody understands it. It's a mess. Can't reproduce anything. This also manifests when you're not doing well. It manifests as fear of the deploy process, because anytime something goes wrong, you basically have to go learn the code base from scratch, right? It's not intuitive. It doesn't have a consistent look and feel. You can't like debug problems that neighbor your area of expertise. And observability lets you watch deploys, find bugs early. I honestly think that, we've talked about how developers should be running their own deploys and watching, taking that original intent all the way out to watch users using it in prod. I have seen that if teams have developers push their own code and they just develop the muscle memory of going and looking at that code after they've shipped it, looking at it through the lens of the instrumentation that they just wrote, right? And P.S., no one should ever accept a pull request if they can't answer the question, how will I know if this isn't working? Right? That's the bar for instrumentation. How will I know if this thing that I'm about to push is or is not working, right? And then you go and you look at it. And is it doing what you wanted it to do? And does anything else look weird? Like, catches like 85% of all problems before users can ever even notice them, right? There's no, because that original intent is going to decay from your head if it's a week from now and you're going and trying to figure it out. Who knows if you're going to remember let alone if it's someone else who's trying to debug what you just did, right? No, the best way to catch bugs, the best way to have, at Honeycomb, we have everyone in one on-call rotation, and about once a week, someone will get paged out of hours. And we've got a giant multi-tenant system with unpredictable traffic spikes and everything. And I'm not even talking about getting woken up. Like, out of hours, we get about one alert a week. This is absolutely doable. It is absolutely possible. But you do have to go and look at it. And you do have to go and look at it when things aren't on fire. You have to know what normal looks like, right? It's not enough to just know how to debug serious problems. Predictable releases is the third thing. And we were saying, quick releases, but then it's like, well, some people's business model doesn't involve, continuous releases, but they should be predictable. They should be no big deal. Like, who here has a do not deploy on Fridays rule? No one is admitting it. Excellent. Yeah, sometimes that's a legit step to take temporarily, right? But you should be kind of ashamed of it. You should be like, here's a Band-Aid that we have to do. Can't wait till we've, progressed to the point where we don't have to do this. Because the number one thing that will make your deploys terrible is when you're batching up multiple changes at once. Do not do that. Like, all of this fear that people feel about deploys is actually legitimate. It's just that what they should be afraid of is batching changes together in deploys, not deploys, period. If you're just shipping one change at a time, oh my God, they're not scary. People should not avoid doing deploys. And observability helps here because, everything about this can be instrumented. Everything about this should be transparent. It should be receptive to a curious person exploring. Complexity and tech debt needs to be managed. This is the fourth thing. You should be able to answer any question without shipping new code. Because if you have to ship new code, well, then you're going to have to restart everything, and bugs going to go away. Haunted graveyard. That was my favorite thing. Yeah. Observability helps you do the right work at the right time. And this, honestly, this is what helps teams win. I have a team of 7 people, and when I look at what we've shipped over the past year, it is an amazing amount. But it's not necessarily that much more than other teams that I've worked with, but we have done better at shipping the things that needed to be shipped, right? And in order to ship the things that need to be shipped, you need to be up to your elbows in prod every day, right? Seeing how users are interacting with what you're doing, improving things, making sure that the work that you're putting into it is having an actual impact. I don't know how people expect to pick the right things or do the right work if they are constantly interrogating production. And finally, understanding user behavior. This is everyone's job, right? This isn't just the PM's job, because your code meets reality where users interact with it in production, right? That's a magical place. That is the only thing that matters. It does not matter if your test can pass, if it breaks in prod. It doesn't matter. Nothing matters but production. Teams should share a single view of reality, and observability will ground you in that reality. And sometimes people will protest, but I don't have the time to invest in it, which is a chicken and the egg problem. And in fact, you can't afford not to, because you waste so much time. Let me tell you about all the time that you waste. There's a Stripe developer report recently where they showed that they surveyed thousands of developers. About 42% of every engineer's time goes to doing things that do not move the product forward, that are often frustrating, time-consuming, trying to figure out where in the code is the right piece of code to fix. Fixing it is probably pretty easy. Figuring out what needs to be fixed, that can take all week, right? A lot of that can just be cut out if you can just see what you're doing, where you're going. You really can't afford not to. Engineering quality of life is tightly linked to high-performing teams and resilient systems. And if you're into all of these newfangled, chaos engineering, blah, 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 observability is kind of a prerequisite for those things, too. In conclusion, for thinking about the future, I think we now have a consensus that, on-call is everyone's job. Everybody has to support what they're writing in production. And it's actually key to doing a good job as an engineer, is actually observing it all the way out to the end of its life cycle. And on-call must not be miserable. I think of it kind of like on-call is going to be less like a heart attack and more like diabetes. Or maybe dentist visits. I don't know. It might not ever be pleasurable, although I have seen it be pleasurable. It can be a really nice break in the routine. It can be permission to go off and fix all the little things that you can't really justify doing during your normal week, right? I think it's a good idea to have a policy of you do not do normal project work during your on-call week. That is a week where you get to work on all the other things. Work on your deploy scripts. Work on your deploy pipeline. Work on all of the little things that kind of bug you about everyone else's stuff that, well, don't take that too far, but work on the operability, work on resiliency, work on the things that contribute to on-call not being a nightmare. Often people will ask me how to think about instrumentation, and honestly, I just say, look at how serverless does it. That's the correct lens, right? You should be observing the world through the lens of the instrumentation that you write. You can instrument almost any code. And deployless is coming. I don't know if y'all have been paying attention to the stuff that Dark is doing, but it's so cool. They're just writing code on production. It saves it and runs unit tests. And this is other cool stuff that I've seen people doing where it'll embed a Sparklines graph. So when you're modifying a function, it shows you the estimate of how long it took to run and then estimates how long it will take to run after the change that you just made. So freaking cool. Tightening these loops, better for everyone, right? Invest in your deploys, democratize access to this data. Don't be too scared by regulations. In almost every case that somebody's been like, well, I can't have my developers be on call because, regulations, they have been wrong. It is bullshit. We are cargo culting that stuff. There are ways to do this because this is how we build quality services. Where there's a will, there's a way. And I was talking about the glass castle, right? And I feel like where we built this glass castle, developers and operations together, combining forces to make everyone miserable, that was a mistake. We should have built a playground. We should have built a place where people feel invited to come and experiment and see the consequences of what they've done, what they've built. See how we all as human beings, we deeply crave the impact, right? We crave autonomy, we crave meaning, we crave impact, and production is where you get all of these things. Build your devs a playground. Build guardrails. I mean, we expect children to get, a bloody nose at the playground. We don't expect them to die. So, invest in tooling to make it safer. But we're all partners in this. Build guardrails. Encourage curiosity. Emphasize ownership. Don't punish people for making mistakes because you make mistakes too. We all do. And our shit is failing all the time. It's fine. It's probably fine. It'll be fine if we practice. Practice failures. And finally, senior engineers, your job is to amplify the costs that are hidden, right? Your job is to surface things. Decision makers are making the best decision that they can with the information that they have, and they often lack what's in your head. A lot of the time when you're grumbling about something, a decision being bad, that's because you know something that the decision maker did not. They did not know that they were building something that was going to be impossible to maintain. They did not know that they weren't allocating enough time to testing or whatever. They didn't know, they didn't know these things, and it's your job not to just say it once, but be a squeaky wheel, to be constantly providing the right amount of signal so that the decisions that get made are good. Communication is absolutely your job. So, in conclusion, all this stuff is changing, but I actually think it's going to be all right. I think it's going to be good. I think that the shape of the changes all point to a more democratized, more empowered, more necessary labor force of engineers who get to come to work and bring their full creative self and feel very invested in what they're doing. So every engineer org has two constituencies, and this really just nines don't matter if users aren't happy, but great teams build great systems. Burned out people do not make great teams. So everyone should get enough sleep, and everyone should feel like an owner. So we have the opportunity to make things better. They won't get better unless we make them better. So we should do it. Thanks.